Next point we are going to see terms used in coordination chemistry. Now here first term is coordination sphere. Now what is meant by coordination sphere? Now this example, by using this example we can explain what is coordination sphere. Now the square bracket which possesses central metal atom or ion and the ligands attached to or bonded to this central metal atom is called as coordination sphere. The central metal atom or ion and the ligands bonded to it enclosed in square bracket is called coordination sphere. Now this is nothing but coordination sphere. Now second, complex ion. Now look here. This coordination compound when undergo dissociation in water, then this Cl minus 3 Cl minus ions undergo dissociation and formation of this CONH3 3 plus ion and 3 Cl minus ion takes place. Then here this coordination sphere contains central metal atom bonded to ligands, and total this coordination sphere carry some charge on it. This charge on this, and this is called as complex ion. The coordination sphere containing central metal ion and the surrounding ligands together carry a net charge. It is called complex ion. Now here this CONH3 6 times, this is a coordination sphere, and this coordination sphere carries 3 plus charge. Therefore it is called as complex ion. This is complex ion. Now third, counter ions. Now the counter ions are those which are present outside the square bracket. Now look in this example. In this example, this K4 is the counter ion, and in this example, this Cl3 are the counter ions. The ionizable groups which shown outside the square bracket are called counter ions. That is, these groups or these atoms or ions easily undergo ionization, and therefore they are written outside the square bracket and are called as counter ions. Now we can explain this by using the dissociation of these two compounds. When these two compounds undergo dissociation in water, they forms 4 K plus ions, and here FeCN6 4 minus. And this when undergo dissociation in water, then here formation of CONH3 6 times 3 plus 3 Cl minus ions. That is, here this CONH3 6 times is a coordination sphere. Then this CONH3 6 times 3 plus or this FeCN6 4 minus are complex ion. And the ions or atoms or groups which are present outside the square bracket and which can easily undergo ionization are called as counter ions. This is also counter ion. These are the 3 terms which are used in coordination chemistry. Next point we are going to see charge number of complex ion and oxidation state of central metal ion. Now here first we are going to see charge number of complex ion. Now for example this FeCN6 4 minus. Now this is a complex ion and total charge present on this complex ion is the charge number of complex ion. Therefore, the charge number of this Fe(CN6) 4- is -4. Now here the net charge present on the complex ion is its charge number. That is, the charge which is present on the complex ion is its charge number. Charge number is the algebraic sum of the charge carried by the metal and the ligand. That is the oxidation state of this metal ion and total charge on ligand is the algebraic sum of this oxidation state of this metal and this ligand. Now charge number of complex ion is equal to oxidation state of metal ion, charge on the ligand. Now here in this example, that is Fe(CN6) 4- in this complex ion, the charge number of this complex ion is -4. By using this charge number of complex ion, we can calculate the oxidation state of metal ion. The charge carried by metal ion in its oxidation state is called as oxidation state of metal ion. The charge carried by metal ion in its oxidation state is called as oxidation state of metal ion. Now we can calculate the oxidation state of metal ion by using charge number of complex ion. Now we know that the charge number of complex ion is equal to oxidation state of metal ion and charge on the ligand. Now we can calculate the oxidation state of Fe in case of this complex, that is Fe(CN6) 4-. Now here the charge number of Fe(CN6) 4- is -4. Oxidation state of ion we have to calculate. Charge number on ligand, now there is Cn ligand and charge number on Cn is, or charge on ligand is -1 and there are 6 Cn-, therefore it becomes -1 multiplied by 6. Therefore oxidation state of ion is equal to +6 -4 is equal to +2. That is, therefore oxidation state of Fe in Fe(CN6) 4- is +2. In this way, we can calculate the oxidation state of central metal ion by using charge number of the complex ion and the charge on ligand. Next point, we are going to see the coordination number of central metal ion. Now here we can understand by using these two examples. Now in K4 FeCN6, in coordination sphere, this Fe, that is central metal ion, is bonded to 6 Cn ligands. Now here each Cn ligand donate a pair of electron. That is, this 6 Cn donates 6 pairs of electrons to the central metal ion, and therefore the coordination number of ion in this complex is 6. Now in this case, second example, this is CONH3 6 times Cl3. Now here this cobalt or central metal ion is bonded to 6 NH3. Each NH3 donate a pair of electron to the central metal ion and forms 6 coordinate bonds with NH3. That is, the coordination number of cobalt in this complex is 6. This Cn means coordination number. Coordination number is also denoted by or abbreviated as Cn. Now we can define from this the number of electron pairs donated by ligand to the central metal ion is the coordination number of the central metal ion. That is, the number of electron pair donated by ligands to the central metal ion is the coordination number of this central metal ion. Now this is next example, COEN thrice 3 plus. Now this En is nothing but ethylene diamine. This ethylene diamine is a bidentate ligand. That is, each ethylene diamine donate 2 pairs of electrons to the central metal ion, and there are 3 ethylene diamine, that is 3 multiplied by 2, that is 6 electron pairs are donated by this bidentate ligand, that is ethylene diamine, to the central metal ion. Therefore, here also coordination number of cobalt is 6. And in this case, this is oxalato. This ligand is oxalate ion. Now this oxalate ion donate 2 pairs of electrons to the central metal ion. That is, here there are 3 oxalate ions, that is 3 multiplied by 2, that is 6 electron pairs are donated by these 3 oxalate ion to the central metal ion. Therefore, the coordination number of ion in this complex is 6. That is, here in this case, it is bidentate ligand. That is, this ethylene diamine is bidentate ligand, and C2O4 is, that is oxalate is bidentate ligand, which can donate 2 electron pair to the central metal ion. Therefore, 3 multiplied by 2 electron pairs are donated by this C2O4 to this ion, and therefore coordination number of ion is 6. In this way, the coordination number is nothing but the number of electrons pairs donated by ligands to the central metal ion. Now we are going to see what is meant by double salt or coordination compound. Now here, when combination of 2 or more stable compounds is carried out in stoichiometric ratio, then we'll get 2 types of compound, double salt and coordination compound. Now we are going to see what is meant by double salt and what is meant by coordination compound. Now this double salt is nothing but mixture of 2 or more salts. For example, Morse salt or ferrous ammonium sulfate salt. Now here, this ferrous ammonium sulfate is the combination of ferrous sulfate and ammonium sulfate. When this ferrous ammonium sulfate or Morse salt undergo dissociation in water, then here we'll get the various types of ions, that is Fe2 plus ions plus SO4 minus ions plus NH4 plus ions. That is, here 2 SO4 minus ions are formed, then 2 NH4 plus ions are formed. All are in aqueous state. That is, each component present in this double salt undergo dissociation to give various types of ions. Either they are positively charged or negatively charged. Now, this coordination compound is also the combination of 2 or more stable compounds. Now when this coordination compound undergo dissociation in water, then here we'll get 4K plus ions plus FeCN6 4 minus ions. That is, here this potassium ion is formed along with this complex ion. That is, this complex ion does not undergo dissociation. That is, here we will not get Cn minus ions or Fe2 plus ions, etc. That is, these coordination compounds are stable compound, and this complex ion which possesses central metal ion and ligands which do not easily undergo dissociation. The bond between central metal ion and ligand is strong and rigid. This is the difference between double salt and coordination compound. Double salt, when undergo dissociation in water, each component undergo dissociation to form ions. But coordination compounds, when undergo dissociation, then only counter ions undergo dissociation, and complex ion is does the bond between metal and ligand present in complex ion and does not undergo dissociation. That is, here when coordination compound undergo dissociation, will get counter ions and complex ions.